Good evening, sir.
Good evening, all. How are you?
Good, sir.
Good evening, sir.
How are you,
Sir,
people?
I'm fine, sir.
Fine, sir. How about you?
Yes, I'm doing good. Is everyone doing good?
Yes, sir.
Sir, I'm doing good,
Yes,
sir,
sir.
except that I don't know how the cross multiplication method of solving linear equations in two variables, how is it derived?
Where it is easily known.
You be quiet.
I'll teach you cross multiplication of I'll teach you that. Okay, We'll start now. What was your problem? Cross multiplication of two linear equation and two variables.
Yes, sir.
But suppose if I have something like this, beta 2x plus y and 9x plus 5 is equal to 2 by 3, something like that. Okay, this type of
Yes,
question,
sir.
or you tell me any question. How to cross multiply this into this into this. So 3 into x plus y is equal to 2 into 9x plus 5. So 3x plus 3y is equal to 2 into 9, which is 18x plus 10. So what I do now? So shifting this 3x to this side. So 18x minus 3x. Shifting this 3y to this side minus 3y plus 10 is equal to 0. So how it becomes now? 18x minus 3x, 15x minus 3y plus 10 is equal to 0. This is the equation which you have to do. After cross multiplication, this is how we get Bhargav.
Sir, not that, sir.
There, that pairs of linear equations, sir. Cross
That
multiplication.
pair of
Tell me
linear
any question.
equations in two variables.
Tell me any question. Tell me any question.
Sir, x plus y is equal
Sir,
to 4 x plus y is x minus sorry
Plus
x
y
plus
is
y
equal
is
to
equal
4.
36. Sir, 36, sir, 36.
X plus y is equal to 36.
No, sir.
Sir.
First equation minus, sir.
Anything you tell me, anything. X minus y is equal to 4. Okay.
X plus y 36.
Okay. So solving these two, this is what you doubt, Bhargav.
Yes, sir.
Now look at this. If I add this, so what happens? Minus y plus y will get cancelled. 2x.
Sir, no, sir, not that, sir.
Then tell me which
Sir,
is
I
the
know.
best?
Sir, I know
If
this
you tell me
method,
the
sir. This is
question,
elimination.
yeah, elimination. If you tell me the question so that I can.
Cross
Sorry.
multiplication, sir. Wait, sir. I'll sir, wait, sir.
Cross
I'll send you.
multiplication of what you say so that if tell me the question so that I can understand it. I'll teach you in a better way. Yeah.
Sir, like we take an equation and we take a b of equation 1 and a b of equation 2 and we write those down like a1 a2 like that, sir.
A1, A2, that is different, I think you are saying. He is asking something different. What is that? Bhargav, you tell me
No,
that.
sir, like we write down them and we multiply like x by a minus a or something like that, sir.
Sir, wait, sir. I'm taking screenshot and sending you, sir.
Send in voice app. Or else
Okay,
you send
sir.
me WhatsApp, no problem.
Sir, I'll send in Zoom chat, sir. Sir, I sent it to you.
Okay.
Sir, in Zoom chat.
No. You send me WhatsApp. I think I have to download it again. Why? Send me WhatsApp. Make it fast. Yes, guys. So we were discussing with what real numbers, right? Yeah. He doesn't want this type of Dipsika. No. Dipsika, no. I think he is asking something different than this. Quick. Bhargav, what happened?
Sir, I was opening WhatsApp web, sir. Now I'll send, sir.
Oh, you are saying solving two quadratic equations concept?
So no, sir. Solving two linear equations concept, but in cross multiplication method, sir. I
Okay.
sent you the picture, sir. You can see that in WhatsApp.
Sir,
That
we
is-
have elimination, substitution, and cross multiplication. He's asking that one.
Yes. Who has sent me the picture? Whose number is this? Akshara. Yes.
Sir, 8008419191 is my number, sir.
No, that is okay. But look at this here. I'll tell you now. For suppose, yes, exactly. Solving pair of linear equations by using cross multiplication method you are asking. So the father we have, let's say that for suppose if I take a linear equation like a1x b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. These are two linear equations which you have in two variables. Okay, so first suppose better look at this here. I'll be writing what? I'll be from this we have a formula. What is the formula? You should know that for getting x by b1 c2 minus b2 c1 b1 c2 minus b2 c1 y is equal to c1 a2 minus c2 a1 is equal to 1 by a1 b2 minus a2 b1. Okay, this is the formula. Now your question is what?
Sir, I don't know how is this formula derived, sir.
You want to derive this? Very simple.
Yes, sir.
Basically, there is a concept. You'll be learning in class 11th as well again. By using this concept, we can find out number of solutions basically. Okay. First of all, we need to compare the ratio. If at all a1 by a2 is not equal to b1 by b2, there are several conditions. We didn't even start this lesson actually. When we start this lesson, I'll tell you. Okay. Don't worry, for proving this, simply you can write like this. Okay, x, y, x coefficient, y coefficient, and constants. Okay, Bhargav. And I'll be writing, look at this b1.
Sir, can you repeat x code?
No, this is x, y, and constant. Okay, x, y, and constant.
Yes, sir.
Now, here I'll be writing b1, b1. So b1, b2. And at last, I'll be writing b1, b2 again. Okay. Okay, in the middle you will be writing C1, C2. Again here A1 is missing, right? A1, A2. Cross multiply, cross multiply. This into this minus this into this. Check. So x divided by b1 cross, sorry, b1 c2 minus b2 c1. Correct, beta? That's how we got. Again c1 a2 minus a1 c2 or c2 a1. Correct. Constant. This divided by a1 b2 minus a2 b1. Correct.
Yes, sir.
Understood? Any doubts? That's how we got, beta. You'll be learning again, so don't worry. So we were going with the real numbers. Hope it is clear. So if you apply this concept, if you apply this formula, you can solve that. Okay, very simple concept. Now I think till what we discussed in the last class, terminating decimals, non-terminating decimals, have we learned? Have we learned
Yes,
or
sir.
not? Yes. Terminating, non-terminating. How to check a given rational number is a terminating or not?
Yes, sir.
Yeah. And we were solving a question as well. Okay, we started solving questions, right? I'll go with questions today. Okay.
Sir.
Find the LCM of 30. Basic question. I'm going to start with the basic to advanced questions. Okay. 657. Make it fast. What is the LCM of this? Reply in chat box. Don't reveal. I need an answer from everyone of you, beta.
Done, sir. I've shared.
Yes. What about others?
Sir, when I shared.
Great.
And even I.
Sir, I also shared. Sir.
Good. I'm getting so many responses. Great, 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 beta.
I want to check my answer. I'm having a doubt in the calculations.
Sir, I sent the answer.
Bhargav, Satvik, Aditi. Yes, Aditi, you're right.
I sent it to sir.
Shreyan, Satvik, Bhumika, Mohit, Pranav, Kavya, Vivek. Fantastic job, you all. Deepsika, Yukta, Bhargav. Fantastic job, beta. Nice job. Okay. So 223338. This is the answer. Hope you all got this answer. Hope you all got this answer. Any doubts?
No doubt, sir.
No,
No,
sir.
sir.
No doubt, sir.
Now I'll give one more question now. The question is, one second. अरे यार ये क्या हो रहा है? एक मिनट. Yes, yes. Tell me. Any doubts in the first sum?
No, sir. No, sir.
No doubt, sir.
Yes. The beautiful question now. Look at this. Oh. Yes. Yeah. And hello. Who is that? We are to odd positive integers such that a greater than b Then prove that one of the two numbers a plus b by 2 quick.
Sir, this doesn't make sense, sir. This question.
Why?
So I didn't understand the question, sir.
Wait. 6 points. Sir,
So,
yes,
sir,
sir. Now
a
it
plus
makes
b
sense.
plus a plus b by 2 is a number.
Yeah. Yes, look at this.
So can we solve the equation using like taking a and b as 2n plus 1 and 2n plus 3 and n as an integer? Can we use that method?
Sorry.
So can we solve this question by like substituting a and b by 2n plus 1 and 2n plus 3 where n is an integer?
Okay. Look at this. No. I'll tell you how to solve it.
Actually, it's a long process.
Yeah. Look at this here. A and b are two odd positive integers such that a greater than b. Prove that one of the two numbers, this and this, is an odd and other is an even. How? Why can't it make a sense, man? It makes a sense. Look at this here.
Sir, as wrong, sir. It makes sense, sir.
No. See here. Odd positive integers. So it could be what? Let us say, so he has written a number in terms of a and b. So let us write in terms of p and q. So let's take one number as 4p plus 1 and or any number you say 4p plus 3. This is both are odd numbers or not? If p is equal to 0, still this be odd, and if p is equal to this will be odd. If p is equal to 1, any number, p value could be any number, 0, 1, 2, 3, any number you substitute, they will be still odd number only, correct? Understood my point? Let be an odd positive integers for all whole numbers. Okay, understood? Any doubts here? Given what he has given,
No doubt, sir.
tell me.
Actually, I disconnected. Can you once again explain how we got 4p there, sir?
How we got 4p?
Yes, sir.
You can take any 2p, you take, no problem.
Oh, yes, okay.
You can take anything. It's not to be 4 only.
Okay.
For example, I'm writing. Okay. So, which
Okay.
means p could be any number. There should be, if I write p as 0, 1, 2, 3, in place of p, if you substitute any number, that gives you a whole number only. Sorry, odd number only. That is the meaning of that. Okay.
Yes.
Is it clear? Is it clear?
Yes, sir.
So now look at this here.
Yes, sir.
So look at this here. For suppose, for example, you say any example you choose. For suppose a is equal to, let me choose 4p plus 3, and let a is equal to this number and b is equal to 4p plus 1. Okay. So but look at this here. He is asking for what? Prove that one of the two numbers, this and this, is an odd and other is even. Okay. So we have to prove this. So a plus b by 2. Let's talk about given a plus b by 2. So a plus b by 2 is nothing but what? 4p plus 3 plus 4p plus 1 by 2, which is nothing but 8p plus 4 by 2. Correct? All right. So if I take 4 common, what is going to happen now? 2p plus 1 divided by 2. 2 2s are 4. So 2 times of 2p plus 1. Okay. What type of number is this? Which is, it is a clearly even number. It is an even number or not?
Yes, sir.
Why it is even
Yes.
number? Any number, if you multiply the 2, it become always even. Dana. All right.
Yes.
Any number you multiply 2.
Sir, but why did you take only 4 years, sir? Like in the beginning, why did you take
2.
4p only?
Wait. You take any other number. Take and try. You will get. This answer will be differing. Kavya, understood? If you take
Yes,
some other
sir.
number, this answer will be differing. It shows clearly even number only. Understood my point? If you get,
Yes, sir.
sometimes look at this here. You might get 4 here. Then 4 into some number is always even or not. Correct? So that is how I'm telling.
Yes, sir.
Okay. Now you take a minus b by 2. 4p plus 3 minus 4p plus 1 by 2. So 4p plus 4p will get cancelled. What you left with now?
We have 2 by 2.
3 minus 1 by 2. So 2 by 2, which is odd number. Look at this odd number. So I proved, look, this is an odd number. This is an even number. Check. Any doubts? Any doubts, beta?
No, sir.
No, sir.
No.
Then hence proved. So a plus b by 2 and a minus b by 2 are even and odd numbers respectively. Correct? Any doubts? Any doubts, beta?
No,
No, sir.
No doubt, sir.
Good.
No, sir.
I'll give one more question. I need a response from every one of you. Are you guys able to understand?
sir,
Yes, sir.
like any two integers which are consecutive, sir.
Yeah.
Which is
Prove that the product of two consecutive positive integers is divisible by 2. Product of two consecutive integers. So one, for suppose 1 and 2 you take. 1 and 2 are consecutive integers or not? Positive integers. So product is what? 1 and 2. Product is what? 2. So 2 is divisible by 2. That's it. Like that. So you have to prove like that. You can't take an example and sir, I proved. You can't say that. You have to take and proper, prove it properly. Let's see how many of you are guys going to prove it properly and show it to me.
So is it correct, Samaj?
Sorry.
So is my answer correct, sir?
No, you can't say 3 into 4, beta. No, that is not correct. For example, that is correct. Okay, Aditi.
So I sent the wrong answer, sir. Like I need to type more.
No
Sir,
problem.
I sent my answer.
Dipsika, it is not like that, beta. Yeah. R lies between two. Okay. No. I'll tell you properly. Look at this, everyone. Those who are not understood, look at this here. By using Euclid's division lemma method, we'll be solving this question. Okay. Prove that product of two consecutive positive integers. You take any product of, two positive consecutive integers. Let integers as
X and X plus 1.
x and x minus 1, or x minus 1 into x minus 1 and x. Correct? Their product is what?
X into X minus 1.
Which is x square minus 1. Till this, any doubts? Any doubts till this?
No, sir.
Okay.
No, sir.
No, sir.
And what we know here? See, you take any positive integers. any positive integers. Let's say that, let's say 2p and 2p plus 1. Sir, why did you take 4p plus 1 and 4p? You can take like this, no problem. Look at this. Okay. By using Euclid's division lemma, how can I write this method? What is Euclid's lemma method? What was the formula for that? A is equal to BQ plus R, right?
BQ
Yes,
plus
A is equals to BQ
BQ
plus
plus
R.
What is B here? By Euclid division lemma. Division lemma. B is equal to what? 2 here, correct? Isn't it? Yes or no?
Yes, sir.
So now what can be my x value now? What is x here? X is 2p.
2p.
So what we have, what is the product we have here? Let us consider this equation number 1. From the equation number 1, x square minus x. If I substitute here now, 2p square minus 2p. Okay, 2p square means 4p square minus 4p. Correct?
Sir, how can it become 4p?
Yes, sir. How does it become 4p?
Sorry, not 4p, 2p only. My bad. It is 2p. Correct? So can we take 2p common? 2p common is nothing but 2p minus 1, or else you take, we'll do one thing, 2p common or 2 common. If you take 2 common, what we left with now? 2p square, right? 2p square minus p, correct? Now look at this here. Can we say now? So look at this here. So we can say that divisible by 2, correct? Is it divisible by 2 or not now? Hello?
Yes, sir. It is divisible.
It's a divisible by 2. Very good. Now we'll talk about first. This is my case 1. Case 1 I took this. What is the case 2? X minus 1 is equal to what we had, beta? X minus 1 is equal to what?
2p minus.
X minus 1 another number, right? X minus 1. Okay. So x minus 1 is equal to, can I take 2p plus 1? I mean, x is equal to, here x minus 1 is equal to 2p beta. If what I did here, x is equal to 2p, I equated. Now x minus 1 is equal to 2p, I'm equating. So x becomes what now? 2p plus 1. So from the first equation, look at this, x square minus x. So substitute here now. Minus 1, correct? Isn't it? So now look at this, 4p square plus 2p. This will get cancelled. What can I take common now? 2 common. Oh. 2ab, 2p minus 1. Am I correct? Is there any mistake? We made a calculation mistake. Check a square plus b square. Okay. So what can I take common now? 2 common. Huh? So 2p plus p. Now check. So 2p square plus p. Look at this again. This is divisible by 2 or not? Again, 2p square p. 2p square plus p is divisible by 2. Divisible by 2 or not, guys? Any doubts here? People, any doubt till this? So product of, therefore, can you say now? Product of any two consecutive numbers. Two product of two positive consecutive. Two consecutive is a product of two consecutive positive integers. Let us write like neatly. Positive integers. Correct? Any doubts? Guys, what I did here, I didn't do anything better. Look at this. I took one number as x minus 1 and x, two consecutive integers. Sir, why did you take x minus 1 and x only? Why can't we take any other thing? Dipsika, can you hear me now? It's a very simple beta. Any doubts here? Guys, any doubts?
No, sir.
Okay. So I took their product. Their product is
Sorry,
11.
why did we take B here, sir?
Sorry?
Why did we take B is equal to 2?
Where B is equal to 2. Better look at this here. As per the formula, as per this formula, look at this here.
Yes,
A is equal to B cube plus R. What is R here? 0. What is B here? Like that. Understood my point? Here B,
Yes,
beta,
sir.
I'm comparing this and this numbers with this form. Okay. There, look at, if you write here, but I wrote, or else you take, instead of P, you can take Q as well. Okay, instead of Q, you write P here, no problem. This form also correct or not? Any doubts?
Yes, sir.
This Q was quotient. Okay, now P is quotient, correct? What is P represents now? Quotient or not? Yes or no?
Yes, sir.
So dividend is equal to divisor into quotient plus remainder. Okay. Understood or not?
Understood, sir.
Understood, sir.
What about others? This is
Yes, sir. Understood.
any doubts?
Yes, sir. Understood.
Very good, very good. Any doubts? Bhargav, Akshara, Aditi, you, Vivek, I don't see Vivek
Sir, no
in the
doubts.
class. Udbhav, are you
No
here?
doubt,
Udbhav?
sir.
Udbhav, any doubts? Satvik, Ritvik, Ritvik,
No, sir.
Nitya, Modita, are you here, Modita? I should see that you are responding in the class, Modita.
No doubt, sir.
Okay. See, you have very, very good talent. You have to utilize that. You can't be keep quiet and simply sitting. You have to respond. You participate in the session, which makes really motivates you. Okay. You Vivek, you as well. Satvik, Ritvik, Pranav, Nitya, you as well, Nitya. Shreyan, Harini,
Yes,
Dipsika participating. Bhumika, good. Any doubt, Bhumika?
No, sir.
Fantastic job. Next question, shall we go? Yes, yes.
Similar type of question or is this the unique one?
I didn't get you.
Sir, can you give one more question similar to this, sir?
We will solve many questions. You can find out. Yes, I'll give worksheet today. I'll give worksheet
Yes.
probably on this. You can find out many questions on this. Okay. Okay, I'll tell you now. Yes, similar questions. Similar type of question means like I'll give a question as homework, not here. Okay, take
Yes.
that question as homework. Okay. Prove that
Yes, sir.
the product of three consecutive positive product of three consecutive positive integers
3p, right?
divisible by 6. You take any three numbers. Let's say that you take this as a homework. I'll give a hint to solve. Let 3 consecutive positive integers are n comma n plus 1 comma n plus 2. If n is equal to 0, 0 plus 1, 0 plus 2. Look at it, 0, 1, 2. These are three consecutive numbers or not? You take any n value could be anything. If you substitute there, you will get three consecutive integers. Yes.
So we can take it as 3p, 3p plus 1 and 3p plus 2.
Yeah.
Yes, sir.
Yeah. No. Look at this here. The question was divisible by 2. So I took 2p and 2p plus 1. Here divisible by 6. So you take in terms of 6. 6p, 6p plus 1, 6p plus 2, like that. Understood, Aditi? आपको
But
समझ
so
में
we
आ
can
रहा है?
even solve in that way. No?
Yes. But better you take with as per this. It makes very easy to understand and it looks very effective, very clear. Okay. Understood, Aditi ji?
Yes, sir.
Any doubt? कोई doubt?
Yes, sir.
Homework. Take your homework.
No, sir.
So total 6 numbers you have to take. Okay. No, why? Because what is B here, beta? What is this B denotes? Dividend or divisor? Divisor, right?
Yes, sir.
The divisor is what? 2 here. Now in this case, what is the divisor? 6. Okay. Understood my point? Divisor is 6 here. So take like 6p plus 1 or 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4, 6q plus 5, like that. Any 6 numbers you take and just, or you 3 number, anything you can take and prove that. Very simple, but same procedure as we solved in the last question. Take it as a homework. Shall I go for the next question?
Okay. Yes, sir.
Guys, this type of questions are very, very important questions, very, very brilliant questions. You could expect in the board exam. Good, Ritik, Yukta, good, fantastic job. I should see everyone responding. If you are not able to talk, please do message. If you are able to talk, please do respond. Okay. Prove that if a positive integer is of form 6q plus 5, then it is of the form 3q plus 2 for some integers q, but not conversely. But not conversely is nothing but beta conversely meaning, what is the meaning of the conversely? If a is equal to b, beta, b is equal to not a. It is not possible. If a is equal to a, if a is equal to b, b is not equal to a. Converse is matlab reverse. Understood my point? Prove this.
Sir, once can you go upstairs that before solution?
I'll tell you that. Don't worry. Why you are wasting time? You just think about this question. I'll share this notes.
Okay.
You can go through that again. Why you are wasting time? Go through
Okay.
this very fast. I'll share right every day. You can go through that later. Solve this question. Any doubts? See, you have to prove that positive integer is of the form 6q plus 5. Then it is of the form 3q plus 2 for some integers q, but not conversely. I'll tell you what is this. Are you all able to understand? Think, don't remember anything. Please try to think. If you do not understand, go and watch it, watch the recording video again, or you do one thing, go and have a look at the notes again, revise it, analyze it, understand it, and come. If you do not understand, you will not be getting marks in the exam. Please understand and proceed. Without understanding, don't proceed for the next question. Okay, at home, please try to go and revise it once again. Try to understand. If at all you get any doubt, ask me in the next class. Prove that if a positive integer is of the form 6q plus 5, then it is of the form 3q plus 2 for some integers q, but not conversely. Okay, so what is the number given to you? Let n is equal to any number. This number I'm taking 6q plus 5. Okay, be as some positive integer. Okay, any positive integer, look at 6k plus 2 given. Let's write in terms of any positive integer. Positive integers of the form you write like this: 3n plus 1, 3n plus 2. All these positive integers or not? Am I correct? Understood now? What is q now? What is q value, beta? See here, it is looking like Euclid's division lemma or not? Hello? Or else you take another value over here. You take 3a plus 1, 3a plus 2. What is q now here? What is q?
Yes, sir. Sorry.
Here, q is equal to what? 3a
Yes.
or 3a plus 1 or 3a plus 2. It could be anything, right? Now let me tell you. In case 1, I'm talking about case 1. If q is equal to 3a, then what is n value is going to be? 6 into 3a plus 5. So n is equal to 18a plus 5. Okay, 18a plus 5, right? 18a plus 5. N is equal to 18a. 5 can be written as 3 plus 2. N is equal to 3 common 6a plus 1 plus 2. Isn't it? Understood my point? Look at this now. How it is looking like now? Beta, comparing or not? Is it what we have to prove here? Look at it here. Prove that if a positive integer of the form something like this, then it is of the form 3q plus 2 for some integers. It is of the form 3q plus 2 for some integers q, but not conversely. Okay, but not conversely is nothing but it's not possible in reverse. That is the meaning of that. So 3q plus 2, look at this here, 3q plus 2. Understood my point?
Yes, sir.
For some q is said, q could be anything here. For some q is said, look at this here, for some integers q. So now next, look at this. Next, I'll take one other case. If look at this now, you can write better from this. You write like this. Here, n is equal to 3 into, you take this as any number. I'm giving this name as some k plus 2, where k is what? K is equal to some integer or not? K is equal to some integer or not?
Yes.
So that is what he has asked us to prove. Now look at this here. If k is equal to, if q is equal to
3a plus 1.
I took first case q value as 3a. Now another case you take 3a plus 2 or 3a plus 1. Anything is fine. 3a plus 1, 3a plus 1 will take. Then what is n value? 6 into 3a plus 1 plus 5. Arey Babu, I'm substituting here. Let us consider this as a star equation. From the star equation, I'm writing this. Okay. From the star equation, look at this. I'm writing this as okay. N is equal to 18a plus 6 plus 5. 18a. Okay. Plus 11. N can be written as, which is 9 can be written 9 plus 2. We have to, our remainder should be 2. We have to make sure that our remainder is 2 beta. Okay. Why? Look at this here. Why? Because our remainder is 2 or not here? Yes or no? Children, are you able to think here? Don't mug up. Please
9
don't go
plus
blindly.
2.
So what can I take? What can I take common now? 3 common. In terms of 3 cube plus 2, I have to prove. So I have to take 3 common. 1 second.
6a plus 3, sir. 3 into 6a plus 3 plus 2.
Look at this here now. Look at this here now. 3 into 6a plus 3 plus 2. All right. Now let me take this as k. What is k here now? N is equal to 3 times of k plus 2. Where k is what? Some positive integer. Or is it clear? Is it clear? Any doubts?
Please.
Any doubts? Sir, why
No.
you are writing always in the form of n is equal to 3 into something plus 2? Why? Because beta, check the question, read the question properly. Prove that the positive integer of the form this one, then it is of the form this one for some integers. This form becoming this form. What is the meaning of the question? This form question becoming this form for some integers of q. Okay, but not conversely. I'll tell you what is that conversely. Okay. Now third case. If I take third case, if n is equal to, if n is equal to if n is equal to
3a plus 2, sir.
3a plus 2, then from the star equation, what was the star equation, beta? N is equal to 6q, right?
Yes.
Sorry, here q is equal to, beta, here q is equal to, sorry, n is equal to now 6 into what? 3a plus 5. So n is equal to 18a plus 12 plus 5. Okay, so n is equal to 18a plus 17. So what can I take? How can I make this as 18a plus 15 plus 2? N is equal to taking 3 common, 6a plus 5 plus 2. Correct? Now what is this? This is k. How can you write that as 3k plus 2, where k is some integer. Now if you observe this properly, look at this here. What is the k value we got here? 6a plus 1. Here 6a plus 3. Here 6a plus 5. Check. So we are getting k values of 6a plus 1, 6a plus 2, sorry, 6a plus 3, 6a plus 5. If you keep goes 6a plus 7, 6a plus 9, and so on. Understood my point?
Yes, sir.
Yes.
That is how it is procedure following. Now, very good. Till this we understood, sir. Till this we understood. Okay, very good. Here, so hence you can write hence if a positive integer is of the form 6q plus 5, then it is of the form 3q plus 2 for what is the question? This is the question. For some integer q. Correct? Conversely, now we will be proving what conversely. Conversely. Conversely is nothing but reverse. Conversely, look at this. Now, what can we take, beta? Conversely, 6. N value, what is that? N value given to you 3q plus 2, right? Now, N value is what? Given 3k plus 2. And let's take the positive integer. Let's positive integers are like 6a plus 1, 6a plus 2, 6a plus 3, 6a plus 4, 6a plus 5. Understood? And so on. Look at this total. So 6, right? 6a plus 5. Correct? So now you take, for suppose, if q is equal any value 6k, not 6k, yes, 6a plus 1. If you take 6a plus 1, then what is n value is going to be now? Check. N is equal to 18a plus 3 plus 2. N is equal to 3 common, so 6a plus 1 plus 2. Now, this is some okay. What it becomes now? 6k 6. So 6 plus 1, correct? 6a plus 1 you got. Now if I simplify this, what I'm going to get, beta? What I'm going to get? Look at this. If I simplify this, n is equal to 18a plus 5. Let us write here 18a plus 5. 18a plus 5 I'm getting, correct? 18a plus 5 I'm getting, fine. And this can be written as what? Or else you write like this. 18 can be written as 3 into 6a plus 1 plus 2. So this can be written as now 3 times of k plus 2, correct?
Yes, sir.
Isn't it? So, or else, yeah. Now, what is the converse happening now? Guys, look at this. Conversely, it might not come the same form. So, understood? Beta, conversely is nothing but beta. What I'm trying to say here, if n value is this one, beta. Okay, if I take this as n value, my condition was satisfying. Now in conversely is nothing but if I take this as n value, it is not satisfying. That is the meaning of that. Understood my point? I'll reply you again. I'll explain you again. Here, the meaning of the question is very, very beautiful question. If n value is 6q plus 5, okay, my it was satisfying like 3 plus 2. Here q, in place of q, I was getting this form very easily. In case if I take this as, if n is equal to 3q plus 2, there is need not to be n, there is a need not to be that you will be getting this form. Okay, not necessarily. What I meant to say here, if I take n value is this beta, you will be getting this form. If you take n value as this one, there is a not necessary that you have to get this value, this form only. That is the meaning of that. Understood my point? I'll tell you now. Look at this. If what is the n value beta I took? What is the n value I took? 6a plus 5. If I take 6a plus 5, I am getting this form. Look at this. What is that? 3q plus 2 something form. Correct or not? If I take this n value, I'm getting again this form. Check. If I take again, look at this. If this is my n value, I'm getting again this form. Now conversely, look at this. If I take this as n value, okay, you write if this is the n value, If this is n value, check now. Look at this. Are you getting the same form? Are you getting the same form? Hello guys, are you understanding my point? See here, if I take this as n value, my form should be 6q plus 5 something. Are you getting that form? If this is n value, beta, are you getting the 6q plus 5 form here? Tell me. Hello. If even you solve beta, look at this, you will not get it. Look at this here, 18a plus 5, correct? Or else you take 6 common, so 3a plus, it's not possible at all. We will not be getting that 6a plus 5 form. 6q plus 5 form you will not be getting. Okay, so 18, only 3 possible. 6a plus 1 plus 2. I'm getting again some 3k plus 2 form, but not 6q plus 5 form. Is it looking like this form or not, beta? Is it looking this form? Is it looking like something 6q plus 5? 3q plus 5 is different than 6q plus 5 or not? Isn't it? Both are different.
That is so different.
Both are different. So what I meant to say here is, if I take this as my n value, if I take my n value as, where is that? If I take this as my n value, 6q plus 5, my form I'm getting in the form of 3q plus 2. Look at this, everywhere in all the 3 cases I was getting. If n value is something like this, but n value given you 6q plus 5. Here also n value given you as 6q plus 5. If I take this form, I'm getting my answer as, look at this, 3q plus 2, 3q plus 2, check. And here also look at this, if n value is this one, what is my form I was getting? 3q plus 2. Look at this, 3k plus 2. Everywhere I was getting 3k plus 2, 3k plus 2, 3k plus 2. When you are getting 3k plus 2, if my n value is this one, in case if your n value is this one, conversely it's nothing but reverse. If n value is this one, you are not getting 6q plus 5 form. That is the proof. Understood my point? Understood, guys? Is there any doubts? But what I meant to say here, I'll tell you the process of the
I understood.
Look at this here. If a is equal to b, beta, there is b. If a is equal to, one second, look at this. I'll tell you one simple note. If n is equal to some q, okay, your form you will be getting as n is equal to some 3q plus 2, something like this. This is true. It is happening. Okay, for example, I'm telling you, in case if your n value is 3q plus 2, then you will not be getting again q form. Understood my point? This is not happening. This is happening. Understood my point? Hello. This is example. You know, need not. I'm taking some random chuma, like random example. Understood my point? Simple example. Here n is equal to q, right? If n is equal to q, after simplifying some, after simplifying some things, your form will be this form. It is happening. But if this is n value, reverse is not happening. Understood my point? If this is n value, this I'm not getting. That is the meaning of the question, and we proved that. Okay, guys. So please go through that and watch the recording video if you have any doubts. Okay. So we'll meet up in the next session. Until then, goodbye. Thank you. If at all you have any doubts, come up with your doubts.
Questions should be sent.
Sorry.
Sir?
Yes.
Bye, sir.
What solutions, sir, should we send you in the WhatsApp once we are done?
Which question? Yes, you please have that. I'll ask you. You can send me, no problem. You can send me. Okay. Thank you.
Okay.
Thank you, everyone. Bye.
Thank you.
Thank you, sir.
Thank you.